Good morning, dear students. In today's video, we'll discuss a very interesting topic which is known as quantum mechanical model of atom. So, as we know about the Bohr's theory, Bohr's theory has many shortcomings, and out of all shortcomings, the major one was that it was not in the accordance with Heisenberg's uncertainty principle and dual character of matter. Okay, as both these theories are worldwide accepted, so that's why this is the major shortcoming of this theory. So, to avoid the limitations of Bohr's theory, a new theory came into light which is known as quantum mechanical model of atom. But before we discuss the postulates of quantum mechanical model of atom, we have to understand some terms which are used in the postulates of this model. Okay, so first we'll discuss the terms and then we'll discuss the postulates of this model. Okay, so let's start the term. Our first term is wave mechanics. Okay, so what is wave mechanics? Wave mechanics is actually a branch of science, okay, which is developed by Erwin Schrödinger in 1926. Okay, this is a branch of science which is developed by Erwin Schrödinger in 1926. Okay, and the base of the development of this branch was dual nature of matter and Heisenberg's uncertainty principle. Okay, so on the basis of Heisenberg uncertainty principle and dual character of matter, this theory was developed, and this theory is also known as quantum mechanics. Okay, so this is about the wave mechanics. Now next term is wave function. So wave function can be represented by this symbol which is known as psi. Okay, so to understand the wave function, let's take an example. Suppose there is a coaching institute in our city, okay, which is providing the classes of chemistry and physics. So we can say that by this coaching institute, we can get the information about chemistry and physics. Okay. Similarly, wave function, by using wave function, you can get the information about energy and position. Okay. By using this, you can get both these. Now, come back to the example. Suppose you have some queries in chemistry, okay, and someone suggests you that this is a good coaching institute, you can join this coaching. So only by knowing the coaching institute, okay, only by knowing about the coaching institute, will you be able to clear your doubts? Obviously no. If you want to clear your doubts, you have to interact with the coaching faculty, okay, your chemistry teacher. So similarly, if you have the value of a wave function, okay, so only by knowing the value of wave function, you cannot get the value of energy or the position of electron. You have to operate that value with some mathematical operators. Okay, you have to do some operations to get the value of energy and positions. So in this way we can say that wave function is a mathematical expression from which we can get the information about electron, like its energy and its position. So this is our second term. Now our third term. Third term is Schrödinger wave equation. So in 1927, Erwin Schrödinger gave a mathematical equation which is known as Schrödinger wave equation, which is del square psi over del x square plus del square psi over del y square plus del square psi over del z square plus 8 pi square m upon h square e minus v psi equals to 0. In this equation, psi, you know that it is a wave function. X, y, z are the coordinates. M is the mass of electron. H is Planck's constant. E is total energy. V is potential energy, and psi again wave function. Okay, so you can write this equation in short like this: H cap psi equals to E psi. So first of all, focus what I'm saying, that this equation represents that when you operate psi, with this operator is Hamiltonian operator. Okay, this is a mathematical operator. So when you operate the value of psi with a Hamiltonian operator, then you will get the value of energy and psi. Okay, it is not representing that this value is equals to this value. Okay, it represents that when you operate this with this operator, then you will get the value of energy of electron and psi. Okay, so this is the Schrodinger wave equation. Now I have used the word operator or operation many times. Okay, so let's discuss what is this operator or operation. Okay, so suppose we have an equation 4 into 5 equals to 20. Okay, so in this equation, this sign, okay, this cross sign shows the multiplication operator. Okay, so this expression can be expressed by this, that m cap 4 into 5 equals to 20. Here this m cap represents the multiplication operator. Okay, m represents the multiplication and cap represents the operator, which is equals to 20. So what is operator? Operator is a command or instruction which acts on the mathematical function. Okay, so this is about the operator or operation. This is a mathematical operation, and here m cap is a mathematical operator. So as I told you that if you have the value of wave function and you want to calculate the value of energy for electron, you have to operate the value of wave function. Only then you can get the value of energy. Okay, so Schrodinger did the same. He operate the value of psi with Hamiltonian operator and get the value of energy of electron and psi. So this is how we can get the energy of electron by operating wave function. Okay, so now what about the position? Now we'll talk about the position of electron. So now you have the so now you if you have the value of psi and you want to know about the position of electron, then you have to calculate mod psi square. Okay, mod psi square will give the information about the probability of finding electron. Okay, I am repeating my sentence. Probability of finding electron. Probability means chance of finding electron, means wave theory supports the chance of finding electron. Okay, it does not say that electron present in a exact any exact position. Okay, so this is the major difference between the Bohr model and wave mechanical theory, because wave mechanical theory tells about the chance of finding electron, but the Bohr model says about the exact position of electron. Okay, so now in this way we can say that if for any particular area around the nucleus, okay, suppose this is the nucleus, and around the nucleus for a particular area, if the value of mode size square is higher, it means the probability of finding electron at that area will be maximum, and oppositely, if the value of mode size square will be less, then the probability of finding electron for that area will be less. Okay, so in this way, now we have introduced with the idea of probability of finding electron. Okay, so now talk about the orbital. So what is orbital? Orbital is the area, a three-dimensional region in the space around the nucleus in which the probability of finding electron is maximum. Okay, as I told you that for some areas, mode size square, the value of mode size square will be higher. Okay, and for that areas probability of finding electron is maximum. So these type of areas is known as orbital. So how can we define the orbital? That this is the three-dimensional region in the space around the nucleus in which the probability of finding electron is maximum, is known as orbital. Okay, so here I have represented orbital, which is given by the wave mechanical theory, and here I have shown the orbit, which is given by the Bohr's theory, which says that electron revolves in a exact position, and here is the orbital. In this orbital, as you can see that I have represented some dark or dense areas and some lighter areas. So for dense matlab it means we can say that orbital even in a orbital there can be a region of higher probability or a region of lower probability. Okay, and one more thing about node. Okay, what is node? As I told you that in a orbital there can be possibility of finding higher probability of electron and lower probability, and node oppositely is the area where the probability of finding electron will be zero. Okay, no electron will present there. So this type of areas are known as node. As in this area, this is the area, this is the region of higher probability, this dense area. Okay, this dense area, this lighter area is the region of lower probability, and this area where the finding of electron is almost zero is known as node. So in this diagram, this is node, this is higher probability area, and this is lower probability area, although this is known as orbital. Okay, so orbital can be defined in two parts: higher region or less denser region, or more denser region. Okay, so this is the orbital. Now we can we can understand the postulates of wave mechanical theory. So let's start the wave mechanical theory now. So the first postulates of quantum mechanical model is the energy of electron in atom is quantized. So this shows the wave like property of electron they are considering. Okay, next, this is in the accordance with Heisenberg's uncertainty principle, because quantum mechanical theory tells the finding of that probability of finding of electron. They are talking about the probability. Okay, and similarly, Heisenberg is also said that there is a that it is not possible to find out the exact position of electron. So we can say that this is in the accordance with Heisenberg's uncertainty principle. Next is, it is applicable for multi-electron atom. So obviously it is applicable for multi-electron atom, because the value of psi for any electron can be many values. Okay, so for many values of psi we can say that there can be many orbitals present in an atom. So obviously it will applicable for multi-electron atom. Next, the probability of finding electron at a point within an atom is proportional to the square of wave function, that is mod psi square, and mod psi square is known as probability density and is always positive. So this point we have already discussed. Okay, next is, a wave mechanical model provides three constant n, l, m, which are known as quantum number. Quantum number we will discuss in our next video, okay, in detail. Next is, the information about the exact shape or various atomic orbitals has been provided by this model. Okay, which is the limitation of Bohr's model again. Okay, so these are the postulates of quantum mechanical model of atom. I hope all is clear for you, and if you have any query, let me know.